Good morning, Chem 20s. My lesson today is going to be preparing a standard solution from a solid. You'll notice that we have a new watermark in the bottom right-hand corner. This problem can get solved tonight when Smart Notebook downloads my program again. However, for right now, we'll just have to accept that. In order for us to make a solution, we're going to make something called a standard solution, which means we're going to make something that has a very, very accurate concentration. In order to do this, we're going to use precise pieces of lab equipment, which means the skinnier where we read the accuracy of something, like where I read 100 mils, a beaker has a very wide mouth. So when I read 100 mils or 250 mils, it's not very accurate. It can fluctuate between 5 to 10 mils in that 100 mil range there because it's something called a meniscus. The wider it is, the less accurate it is. So every time we grab a piece of accurate glassware, you're going to notice that it's very, very skinny. And so I'm going to first do a calculation with you to figure out how much mass of copper 2 sulfate we're going to need to make up a certain standard solution. And then I'm going to have you go to another video to watch me make this solution. And you're going to see that I'm going to use glassware that's very, very skinny where the measurement line is, and so that we can see how accurate I'm going to be, and we can actually be as accurate as to 1 decimal place. So the question we're going to answer today is we're going to calculate the mass of solid copper 2 sulfate pentahydrate. So first thing we're going to do is the same thing we always do, is we're going to write the chemical formula out. Now, we are trying to find mass, so that is going to be what my question mark is. My molar mass, we're going to calculate. So we're going to add together 63.55 plus 32.07 plus 4 times 16 plus, we also have 5 times 18.02. Because remember, water is 18.02. So my number comes out to be 249.72 grams per mole. My volume, it says, is 100 milliliters, so we're going to change that to liters. So 0.100 liters. And my concentration I'm trying to make today is 0.186 moles per liter. So if I take a look here, my first step is going to be, I've got concentration and volume, so I can find moles. So my memorized formula is C equals N over V. I'm going to move it around to solve for N. So N equals C times V. So I'm going to take 0.186 moles per liter. I'm going to multiply it by 0.1 liters. And my number is going to be in 3 sig digs, 0.0186 moles. Secondly, I need to find mass, so I'm going to start with my original memorized formula. Mole equals mass over molar mass. And this time I'm solving for mass, so I'm going to bring my molar mass up to the other side. So my new formula is going to be mass equals moles times molar mass. So I'm going to take 0.0186 moles. I'm going to multiply by 249.72 grams per mole. So just take my full calculator number times 249.72. I'm going to put my answer into, when I go back to the question again, 3 sig figs. And my answer is 4.64 grams. So this is the amount I'm going to weigh out on the electronic balance when you go watch me prepare this solution. Now, for me to go prepare this solution, I wanted to give you a list of equipment we would need first. So in order to make my solution from my solid, I'm going to need, of course, copper 2 sulfate pentahydrate. I'm also going to need distilled water. I'm going to need an electronic balance. I'm going to need some weighing paper. I'm going to need a stirring rod, 100 milliliter volumetric flask, an eyedropper, and a beaker. Now, it is at this time that if it was me, I would go watch the video on watching me demonstrate how to make this. However, What I am going to do is, because you're going to have to repeat the steps over and over again, I'm going to put into text form the steps I went through in the video on how to make the solution. So step number 1, I measured out 4.64 grams of copper 2 sulfate pentahydrate solid on an electronic balance. I then took it from the electronic balance and I placed it into a clean, dry beaker. Once in the clean, dry beaker, I'm going to dissolve it in approximately 50 mils of distilled water. Now, this volume is always going to change. If I'm going to make 100 mils of solution, I dissolve it in half of that, so I dissolve it in 50 mils. If I'm going to make 500 mils of solution, I will dissolve it in 250 milliliters of distilled water. Once it's dissolved, I'm going to transfer my solution and all my rinse water into a 100 milliliter volumetric flask. Once in the flask, I'm going to get down to eye level, and with a eyedropper or a disposable pipette, I'm going to continue to add distilled water until the bottom of my meniscus, that's the bottom of this dip here, exactly touches the calibration line. Once that's complete, I've made 100 mils. I'm going to stopper my solution. I'm going to invert it a few times and let the natural air bubble mix it. Then I'm going to pour it into, let's say, another dry beaker so I can use it out of there. What's really important about this is when we go to make this, you cannot spill any, you cannot splash any. If there's any air, if there's any bubbles in there when you're making it, tap the solution, get the air bubbles to rise to the top so that when you are finished, because this is a standard solution, this is the most accurate solution you can possibly make.